Awesome. Hey everyone, welcome to the 14th OTC Talk session. It is really good to have you all here. We will have a talk titled It's Next After React by our very own co-organizer, Darshan Randar. He is an SD2 at UBS. He's been there for 3 years and yeah, a good friend as well. And he's very knowledgeable when it comes to React, coding styles, and just building projects in general. Um, and yeah, excited to have him here. Excited to hear more about him from how about how Next.js and other things generate outputs in the .next directory and how that structure looks like and what actually happens in different rendering patterns. So excited to hear about that. When I heard that Darshan had a talk for that, I was like, okay, I have to ask him to do this here so that we all can learn, because I was unfortunately not able to attend the talk, and I thought it would be valuable for everyone as well. So I think thank you, Darshan, for agreeing to do this. And post our OTC talk session, which should last about an hour or so, we have our OTC catch up session, which will be our 300th session. So it'll be the 300th consecutive Saturday that we've had an informal tech discussion, is what OTC catch up is. So it is a 300th session. Please join us for that. And in the pinned comment in the chat, you'll see a survey link for our catch ups as well. So please go and fill that so that we can know how to improve it and make it better. So after OTC talks, hope to see you continue on for OTC catch up as well. And it'll be in the same meeting. So hope to see you all there. And yeah, over to you, Darshan. Good luck.
Thank you. Thank you. Hi everyone. Let me share my screen. Let's start with the slides. Obviously, how can I present it? Yeah. So it's next after React. Um, it's simply it's a wordplay. It's next because it's meta framework over React. So React is actually not a framework. It's a library. It's a way that things work under the hood. But next is what brings everything together: the caching layer, the routing, and all these different parts, everything like that. About me, I work at UBS. As like over there, I am a full stack engineer. I work on back end, front end, DevOps, everything. It's basically now a joke in my team that मैं धनिया बन गया अभी टीम का, सब जगह थोड़ा गार्निश कर देते हैं मुझे. So yeah, that's about me. Uh, Apart from that, this is my website, darshananda.com. You can go there. So moving, how React used to work at the moment, it's a lot more complicated, but it used to work that server would just send a JS file to the client, that is the browser, and the browser is responsible to run the JS file and show UI to the user, make any requests, make things interactive and everything uh, around the website. Everything was done by a JavaScript file or multiple JavaScript files. That was before. Now, since what, React 17, also have React Server Components, which is essentially we had this server client where we can send HTML, CSS, and JS. So how that works is your server takes that JavaScript, runs it on the server itself, and sends the hydrated HTML and CSS to the client. And the client is just responsible to render the HTML, which browser are very good to do because that was their primary function to do, to render HTML. So yeah, that's the server and client connection. What React does to you, gives to you. Apart from that, they do one more thing. They have a CDN. This is their cash cow. They make a lot of money because of the CDN and how well integrated it's inside the Vercel ecosystem. So yeah, so there are different rendering strategies with Next. There is client-side rendering, server-side rendering, static site generation. We are going to talk about all of these in the later part. There is incremental site regeneration. There is streaming. It's not exactly a rendering strategy, but yeah, you can count it as that. Now, okay, let's talk about them a bit. So client-side rendering is what React used to be. You give the JS, and client is responsible for rendering it. In server-side rendering, the server renders, basically it generates HTML and CSS for you and sends it through the wire to your client, where browser will just render the HTML and CSS, won't run JS to show anything to the user. Static site generation is where the servers that build time, not the servers, but when you're building the project, you would generate HTML and CSS and store it, and then when there is a request made, you just serve that static HTML and CSS to the user. Incremental site regeneration is a bit tricky, because if you think about this, so let's say you are a newspaper site. You might have like a million articles on your site. You cannot do both, right? You cannot generate everything every day. So that is just waste, and you don't want to store everything, because uh, like, who goes and reads news that was published in 1970s? You would want people to have access to the newer one, and maybe you can generate things in the from the database when you need it. So that is incremental site regeneration for you. You define a expiry date for your site, and also you define a revalidation time for your site. So whenever someone comes to your site, if they don't get a static value, they will generate it on the backend, store it there, and then serve the site, the user. And for the next consecutive requests, until that specific time hits, it will keep that old copy as a cache and serve the old same thing to the next user itself. So you save the time for the generation bit, uh, but you only store things that are required. Streaming is another bit where, let's say you have a very big uh, page, right? So a lot of things on your page. Uh, so you don't want to do either, right? You want to have user not to have a client renting strategy itself as a whole, but you don't want the user to wait while your server builds the site. Basically, you just want to show user something on the time where while they are looking at your page, something what ChatGPT does for you, right? You get text while you are reading the next part, it generates the whole paragraph for you. That is streaming essentially. Same thing for the components, for the UI component itself for streaming. Next bit, yeah, there are only two problems: cache invalidation and naming things. To be honest, I hate Vercel a lot, but they nailed this part. The cache invalidation bit is pretty much in control for in your hand. If you want to invalidate a very specific path for a specific user, you have a very fine grained control over it. So that's very great thing about them. Naming things, I don't think so. They did this right exactly. Um Next helps you to manage yeah. The ways you can do it is basically you can have use cache directive and cache life function. You can use that in fetch request. You can validate by tags, by paths, uh, by using these methods. And also there is a revalidate property itself where you can set it to like 30. So it will revalidate the cache after 30 seconds. And yep, code time. So before we move to the code, there are a few things. If you don't know React, it's fine. If you don't know Next, it's fine. It's the talk is mostly about how different strategies work, and what you can gain from them. What are the pros and cons, and where you should use them exactly. So yeah, that's there. Let me move to the slides. Yep. So I'll just show you the site on dev first, then maybe we can move on. Um, so this is the site which I have built. It's dev, so I won't show you the network tab yet. So it's generated site. I haven't written a single bit of code. So if you see, there's a quick reference here. Uh, I didn't add this in the slide because it's here. So CSR is client side rendering, SSR is server side rendering, SSG is static site generation, ISR is incremental site regeneration. So the rendering bit is on the browser for CSR server, and the build time. At the build time, you generate all the sites. So that's it. And ISR is build and background both. We'll come to this on later part. Data. This is where the trade-offs comes in. So data in CSR, SSR are very fresh. So you you know what at the moment your database looks like. It will give that fresh data to the user. SSG is only, so these are where you want uh, data which is in time, right? So you are very this is for data centric applications like stock market and these kind of things where data is your main power. SSG is where it's only build time, so small blog sites, these kind of things where you are fine if the data is stale and takes your build time is like a few minutes. It's fine for small blogs. ISR is periodic, so it goes with the access patterns. SEO, you don't expect CSR to have SEO. It's simply because it's just JavaScript and the engines, the browsing engines and uh, crawlers, they don't understand JavaScript. They don't pull your JavaScript. Uh, so this is CSR is a good strategy if you are building a dashboard. But apart from that, if it is a blog site or any other kind of site, don't use CSR. Uh, REST all are really good with that because they serve HTML and CSS to your browser. So HTML, that's what your crawler needs. Uh, TTFB is time to first byte. So CSR is very fast because all the JavaScript is generated. They just need to send that to the user. And SSR is slow because first a request comes to your browser, to your server. Server kicks in and tries to generate your HTML and CSS, and then it sends that file to the user, sends a response to the user. SSG is very fast because the everything HTML and CSS generated on the site on the server itself, and it just needs to send that HTML, which is generally a bit smaller than JavaScript that is used, and also the JavaScript needs to run on the browser, which takes some time. But SSG HTML rendering is very fast with browsers. ISR is similar in the case. It's basically a mixture of SSR and SSG. ISR. Yeah, server load is minimal. You just serve the JS file. SSR is very high. It's simply because every request generates the site on the server. SSG, there is none. It's you are just serving static HTML, CSS. ISR a bit minimal, but I would still consider as a bit high. Depends on the access pattern on your sites. If you have set up cache properly, then it's there. Loading state, skip that. So yeah, that's about the site. About the site. So I have built multiple tabs. This is client side rendering. You can see the skeleton loads first, and then you get the data. And you know when what's the client time and the render time when it was rendered. Render time shows that it's not so it's basically on the client side. So server didn't render this. Server just sent the response, and it took around like 3 seconds to get the response. SSR, if you go to that, you see when I clicked, it took some time to respond, but yeah, it's still faster to send all the data to the user if it is not so much content heavy. And you can see it was rendered 22 seconds ago. If I refresh the page, you will see it will give a fresh copy to us. The client time and the server render time was pretty close. So yeah, that's CSR. If you go to SSG, it also took some time, but it's because on the dev server. But yeah, it should take zero time for us. Uh, I'll just skip that because SSG and ISR doesn't work very well on the dev side. So yeah, if I go to streaming, you can see it. The sections take some time to load, and then you get the detail. Let me show you that again. Okay, you can see first the main tag load and the related products, and then finally the customer reviews. So it gives you a skeleton, and you stream products accordingly. What's by your priority? You can stream that way. Uh, so yeah, that's there. Let me just um, run it. Uh, Build and run this. Before we run this, let me build it and show you the next folder for you. Yeah. If you see the build command over here, just close this, expand this. Yeah. If you see there is not found, there is product APIs. These, ignore those. If you see, uh, this is your CSR. This is client rendered page, which shows you that it would be just JavaScript. This is CSR slash ID. If you go to the product, this will be called. It is a function. ISR, incremental site regeneration, and you see these are colored dot, which means they are generated beforehand. And similarly for uh, this SSG is generated, SSG slash ID is generated. SSR, both are functional because every time you hit the server, it will run the JavaScript on the server and then gives the response. And same with streaming as well. So that's there. Let's explore the .next folder here. Uh, Everything. So we will ignore the dev file because it's when you run the dev. We'll move to the server, and in the app you see there are multiple HTML files. This is first is the index, which let me start the server. If you do this, it will serve you the generated.next folder. And let me refresh this. So this is the index page which we had. Let me open the dev tools now. I've set it to all. And if I show you this, this is the localhost file over here, right? So it will give you the current page. It's statically generated. We don't need to set anything here. If you see, this is the empty dot, and empty dot is static. Um, so yeah, that's it with this. If we move to the next part, let me just close these things. We move to this. So next is the simpler one is CSR. I really like this. It's pretty simple to understand. You see, it's if I go to the CSR HTML, so you see the CSR HTML, CSR meta, CSR RCS. This is interesting. Like everything will have this three files: meta, uh, metadata, and the RCS. So RCS stands for React Server Components. uh, this text that you see, the random gibberish, it's not random. It's what it's called flight protocol. It's built by React team. So as I said, React Next is built on top of React. So it's a protocol. I don't know if it's open source or what, but if you want to understand this, I stands for include. All these things that we are saying is include these JS files. So whenever you get this RFC server component, it will include these things and these, and it knows that these are static CSS content and these kind of things. And finally, if you come over here, you see how it directs the browser to render this. So 0 and Also over here, some knowledge about that. This is metadata for the browser to set, and finally this is also some metadata, uh, the header folders. This is very basic for CSR. We'll go to ISR, which is interesting in this case. But yeah, so if you go to the HTML page, you would see that. Let me. Ah, nice. I just formatted this so it's easier to read this. So if you see something is already generated, uh, you can see there is a skeleton base also built. Because when we generated this, the code is essentially the skeleton, and all these components are something that don't have any side effects or any API calls or anything like that. So Next checks that out, and it was something that awaited components. So Next sees them and sees that it can build that on the fly before, uh, uh, like it is something that they can resolve at the build time itself. So they do it and resolve it, and finally it adds a bunch of script tags. Uh, so it will get this JS file and start running as soon as it gets that. So what I will do, I'll go to this CSR. One interesting thing that will happen is when you do this, you go to this page, you get all this React component itself, server component. So what this does, every time you load the site and you navigate inside the site, it will not give you the whole JS file or whole HTML file. It will give you the it will give you this React server component, the flight protocol response, which will direct the JS, the React JS or whatever it is. So it will direct that the runtime to build the page from start. So it gives the information to get this JS and run it. And finally, the JS will call the products API. If you see the caller as well, it will you would be able to find that out. So some JS file called this. So that's how it works exactly. And when I refresh the page, if I do this, you would see that this is a document now. So the folder that we saw uh, over here, this is the HTML is only served when you land on this page. In any other case, it will serve this React server components regardless of what's rendering strategy is, and this works for every part of the page, every part of the build. So yeah, that was very interesting to me. I was under the impression it will give you an HTML page or what, but that strategy makes it very fluid, I would say. And yeah, that's that's very simple with client side rendering. Now, if we go to server side rendering, you see, if I clicked on it, it took some time to respond, exactly 1.53 seconds to respond, but it gave us the whole. It again, yeah, it gave us the uh, statically generated page. Sorry, server component. But if I refresh this page, you would see it took a bit more time, 1.56 seconds, but it gave us the generated page itself. You would see it's already hydrated. All the information, 1.3 dot whatever, it's hydrated inside this. And if I go to the page, if I go to the code for this, you would see there's none because it's generated. Uh, Everything that we see is generated over there. If I go to this folder, SSR, this is it. So it goes to the turbo pack runtime JS, and it gives the JS file to that, and finally I guess this runs it. Not very sure about this, but yeah, this runs a bit and exports that finally to build this. Everything else is metadata about that. And if I go to the ID page itself, it's the same. you see the page.js. It does the same thing. It will it will get the runtime and pass it as a function parameter, the page path, JS path, and then finally run this. So I guess it sets up the server with the path and then uh, returns this thing to generate whenever someone gets to the page. I saw, as far as I remember, I saw somewhere there was this server component itself. Let me check that as well. We'll find that later. I feel. Nope, not here. Okay, not here. So essentially, there was one page where one JS file, which is like your React, not React, but Express, Express server kind of a thing, where it will run and generate everything for you. Basically, it is the main server for your Next. So you see, there is no HTML for SSR because everything is generated on the fly. So, yep. Now, the next strategy, if you go to the page itself, any other product page, you would see it takes some time to respond. It will give you this RSC. Uh, an RSC, oh my God, you cannot see this now. Nice. So it will give you the component itself, and then the JS will build the whole thing for you. And it also gives some JS to give the interactivity. So this thing is called partial hydration, or partial rendering, or what, I don't remember exactly. But what it gives you is first it gives you the UI, and then in the later steps it gives you the JS files, which will give interactivity to the client. So after this JS is loaded, I would be able to click on these buttons. Um, so yeah, let's move to the next one, that is SSG, and this is one of my favorite ones. SSG is the fastest one. So if you can see this again, it gives you the fragments, React comp- uh, the React server component. It will give you the server component flight protocol response, because we are moving in the site, and it is much smaller and faster to give you this response than the whole HTML and CSS, even for SSG. But if we refresh this page, you would get the generated page itself, and it took like 22 milliseconds as compared to 1.5, 1.6 seconds. But you can see this, it was generated 12 minutes ago. This is when we ran the build command. It generated in that time, and now you can see it is pretty stale for us. But everything works well because again, it loads the interactivity with JavaScript and some from CSS itself. But if you go to the page again, it took some time because these components, I guess, are not pre-rendered. But yeah, oh, they are. I guess the server component is rendered later. Let me go to the SSD. Yeah, server components are rendered later. So how I'm configured this, let me show you the code as well. Uh, app SSG, the page over here is, we set this dynamic to force static. So which means that we don't want this page to be dynamic. It is static page. Just build it and keep it as the build folder. But if we go to the this ID, the specific path, it will also like dynamic params. We are saying that there are dynamic params, but we don't want to build anything on beforehand. This generate static params is basically things that you want to build at the build time. So we don't want to build anything, but what happens is this. So I can refresh this multiple times. When I click on the first product, now it will be very fast simply because we have generated everything. Now, if we go back to the page, you would see we have one.html and one.rcs. Uh, but if I go to the second product, you don't have the second one. But if I click on this, it will generate this in the build folder. Yeah, you can see we have 2.html and 2.rcs now. Now, at every refresh, it will just give us the old page. And you can see it was rendered like 10 seconds ago. So that's how static site generation could work. So you can do everything at the build time, or you can let it build and keep it forever at like once the user tries to access this. There are pros and cons to this strategy. So you can build it very fast, and once anyone comes to this page, they might have a few seconds of delay, but they would get the response, and next users will forever get the response very fast. Now, coming to the most complicated but most favorable kind of a strategy is ISR. You see that it's 15 minutes old. Let me show you this. Give me a second. So let me copy this and let's go to the ISR page. You can see we have 1, 2, 3, 4, 5. Um, and where is the index page? Oh yeah, it should be here. Yeah, it is here. And if I search for this, great. I need to, yeah. If I search for this text, you won't see. Oh, interesting. Maybe, oh yeah, maybe it's formatted the later part, but we can search for the text itself. So over endo time. Yeah, you can see it's, oh yeah, it replaced this. So now over here in the HTML, we can see it's 1109, and over here it's 1053. If I refresh this, I will get 1109, but it knows that it will rebuild it after every 30 seconds. So it knows that it is 1 minute 25 seconds past. Then, yeah, it regenerated this whole HTML and saved it and replaced the old cache. And if I refresh it now, it will give me a new time. And if I go back and search for this, yeah, search for this now, we can see this. It's here. So that's how it works. It will generate after every 30 seconds. So strategy over here is you are fine with some stale data to the user, um, but next time someone comes to the page or refreshes the page, they will get the fresh data to the user, and they won't see any latency in any sense, because every time you have this, you generate the page on the fly, and then you replace the old cache with the new one. There is one interesting thing over here. I mentioned that it has this 1, 2, 3, 4, 5 things. You can see we have 6 products, but now if I click on the 6th product, it will take some time, similar to what SSG did. But over here in the HTML file, we see it is 6 seconds. Now, if we come back to the page after some time, it will give us the same response, uh, but it will be regenerated itself like every 30 seconds. Let me show you the code for this. Uh, where is ISR? Yep. So over here you see it's revalidated after 30 seconds. There is one more thing, you can set an expiry for this. So let's say you want to generate this page after every 30 seconds, but after an hour, you know the data is very old to show it to the user. Then you just discard the page and let the user wait after an hour if they come, if anyone comes uh, after a revalidation. Uh, Do I have it? No. But yeah, similar with this page as well. It will revalidate this. Uh, yeah. Over here, if we see, uh, it should, if I refresh this now, it will give me the old page. But let's wait for a few seconds. And if I refresh this now, it will give me the latest page. So yeah, that's how ISR works. And now to the final bit. Final bit is streaming. You go to this page. You see, uh, over here. Let me refresh this. See, there are some responses, and if I go to this page now, uh, you can see that we we get the HTML site itself. Let me show you the generated build streaming over here. This is again just HTML, and you see this is SSR. So everywhere where you see the JS page.js, it's on top of SSR. Over here, same. So I guess it just builds everything for SSR, um, and then uses the same thing uh, to generate or to do ISR or to do streaming or whatever. Even for CSR, it uses SSR. Yeah, it uses chunks from SSR. Anyways, so yeah, if you see there is a JS file over here to build segments, but yeah, it just builds everything on the fly itself and maybe caches it somewhere. Uh, we don't see that a lot, but yeah, that's how streaming works. Uh, you stream everything by segment, and everything renders with time. So if you see over here, this is I have added some uh, extra delay between products, between segments for a response. But yeah, any questions?
Hey, Darshan, I had a question. I like the talk, by the way. Thank you so much.
Thanks.
By the way, do you have stuff that you still want to speak about, or are
Yeah,
you done with what you want to talk about?
I'm done mostly with the talk. It's just going through everything again.
Okay, so do you want to do that first before questions, or how do you want to do this?
Uh, I guess let's go with question first. Maybe I would go through everything with the talk, everything after the questions.
Okay, sure. So that we get
Maybe
like a
people will
nice,
be able to connect the dots.
yeah, so that we get like a nice overview at the end. Okay, sure. But
Mm.
okay, I had a question which was about which, like, what are generally the sites that you see for each one? I was mainly interested in which sort of sites use ISR, and then which sort of like what real world use cases have you seen or are there where there are like multiple strategies on the same kind of thing and stuff like that. So essentially, the question is the two main questions. One is what are the for each rendering strategy, what are like some example sites that are available, and the second one is can you like talk about what real world sites use multiple of these together?
Okay, so generally, I would say a lot of sites would do all three. Generally, it's ISR. So, like as I give the example for news sites, they would do an ISR strategy because
Sorry, what
they
can you repeat that?
ISR is essentially you build the page once,
Uh-huh.
keep the cache for some specific amount of time,
Mm-hmm.
serve the same HTML CSS to the every user across. Basically, it's a caching layer on top of your SSR.
Mm-hmm.
Okay. So you cache everything till that specific time,
Mm-hmm.
and in background you regenerate your site again and again.
Mm-hmm.
And you can invalidate the old data, and you have a lot of control over the cache, right? So
So who would
that
use something like this?
I honestly, I don't look a lot at different pages how they are doing
Mhm.
these things, but I can give you examples where these
Yeah, that's
strategies
what.
would fit in. So
Yeah.
ISR would fit in where you have a static site, and the most pages are static, and you don't care about data being very fresh of
Mm-hmm.
sorts,
Mm-hmm.
and you have a ample amount of data, like news sites I gave an example
Mm-hmm.
of.
Mm-hmm.
So for news sites where they have like they publish like 100 articles a day,
Yeah.
right? So they don't want to store every HTML on their server every time. They would
Mm-hmm.
go with this strategy where every time a user clicks on that article, they would save that, build and cache that article at the caching layer, and then serve it to multiple users. Because an article goes viral, then a lot of people would come in,
But-
else
So
no
would
one
it,
would be there.
one thing that comes to mind is, wouldn't like a new like let's take newspaper, they publish 100 a day or whatever. Wouldn't they want to use something like SSG then, where it's like, oh, you build oh, Jai, that's a name I'm seeing after a long time. But yeah, so you're essentially building 100 pages once and keeping. So why would they want to keep regenerating them? Right? Wouldn't they rather go for SSG than ISR?
I would say simply because of the size, right? Because storing text data,
Uh huh.
which changes, like if you, let's say if you go to any newspaper site, uh
Thanks, India.
okay, Times of India. Uh, I don't remember the.
Yeah, that's fine. Yeah, yeah,
So let's see. If you go over this, right,
yeah.
first page. Let's move on to the next one. But if you see, this everything is a template kind of a structure, right?
Uh
My
huh.
God, they would play a video as well. So everything is a template. So you have a
Yeah.
title, you have like 10 things over here,
Yeah.
but everything is a template.
Mm-hmm.
So storing all the information, like generating everything and storing that whole HTML and CSS for every page
Mm-hmm.
is too much waste of a space,
Okay.
right?
So
So
when a user comes on the page after, let's say, 2 days or something like that, for example, so then they'll generate that particular page and
show it
serve
to
it.
the user.
But suppose that story gets popular after 2 days, so they generate that story for the first time after 2 days. But users that come post that get that cached version, so they don't have to
Yeah,
keep generating that. They don't have to have generated that page for the first 2 days or whatever, something like
yeah,
that.
yeah.
Okay.
So generally, news is something that gets very old after a day. Like the
Mm-hmm.
moment it's published, it's old,
Yeah.
right? So
Got it. Yeah, yeah, yeah.
you might cache it for a day and let
Yeah, the
it
other
be
way
there
around
in
from
the
what I said,
database.
but okay. Yes, yes. Fair
Let it
enough.
be there in the database for like forever.
Yeah, Jay had a question.
Yep. Go ahead, Jay.
Okay, maybe not. Does anyone else have any questions?
Janvi, yeah,
Yeah,
go ahead.
Jay, what's up?
Same, like continuing with the same stuff, like the newspapers itself. There are so many papers that are getting loaded, and like, suppose you were telling about like 100. If you assume like there are around 10K papers which I have to display on a site. So, my major question, like currently also I'm working on it, how do we, reduce the time, that loading time that eventually takes, like because loading at the same instant of time, like how do these templates manage all of these? You said there are titles, there are stuff, for every paper managing these stuffs, it gets hectic. But like how does the delay time actually gets reduced? Like I was like searching for it, but yeah.
What do you mean by delay time? Like now?
For suppose you click up paper, like you, okay, before that when you go on a site, there are 10K papers rendering on a go. Okay, so it takes a lot of time for eventually getting all of that papers together. So we
Why do you want to render 10K papers at the same time?
so eventually you load some 20, you limit the size to that. But in that also, like so many things to be loaded. For example, images, URLs, so many things are there. So it takes a lot of delay time basically.
So this is a different. So the main problem here is if you go to the page. So as I showed you the example, like Times of India, there is 10 banners, there is a video playing, there is one image over here, whatever, right?
Yes.
So this is where, right? So there is a loading page. What's God knows what's loading here. There are two advertisements. So yeah, these things, right? So another pop-up. So you're
Yeah,
talking about all these images, right? So
yeah,
that's
correct.
how they are loading, right? If you see. as I scroll down, these things will start loading, and they have a priority order as well. So advertisements have the least priority at the moment. Uh,
Okay.
so you have a priority order. I guess this is a browser native thing as well now, that you can set priorities to your images. So you can set priority to images and how much of the viewport it is covered. So if I go to this, so let's say the browser sees this and they know that next 10 articles are, they already have the HTML, right? So they knows what the next 10 articles images they need to load. So they will do it in the background. Let's see if they made this site right. So yeah, CMS call. Yeah. So as I scroll, you can see that they are loading uh, this images, JPEG images. I will load a bit more. You will see a lot more. So this is how you do it. You react to the user's behavior. There is one specific thing, I don't remember the name exactly,
Lazy
but
loading.
yeah, this is called lazy loading. But this is one more interesting strategy, right? So in React, in Next, I was reading their new update. They have this instant navigations now. So what they will do, if you go to this article, right? If you are around this article, they will sense your cursor area, and at this moment, before I reach this, I before I hover this page, they will start downloading the next page as if I'm going to click on this. So the moment I click on this, they will replace the whole page. So that's how things are moving on the front end side. So yeah.
Yeah, and Darshan, could you also show our Lighthouse, please? Janvi, are you aware of Lighthouse?
Oh yeah.
Uh, no, but the very first term that you mentioned something about skeleton, maybe
Mm-hmm.
I was thinking that maybe this loading and all stuff takes up like faster because of the skeleton wala stuff. But yeah, that was
No,
something.
so skeleton doesn't improves the speed. It just gives you a feedback that something is going to happen in future. It's a loading state. So
Okay.
if you want to see this, right? So I can show you an example. So if you want to check your site, there is this lighthouse. Harsh gave an example. Where's lighthouse?
Number fifth, Darshan, from top.
Oh, yeah, got it. So over here, let's go to my website, right? It's all static site. There is no JS. Like there is some JS, obviously, but it's mostly static. So if I go to this, also the important thing over here is you need to open this in a incognito window, because we don't have any extensions to get involved. So you can analyze this page. It will take a few seconds, and it will give you suggestions about what things can be improved and what images size and all those things. So I got a score of 97. um, so and if you scroll down, this will give you all the information, right? So the first contentful paint is zero point 0.8 seconds. Contentful paint is this basically you get the first pixel on your skin, kind of. First, largest contentful paint is the largest segment or largest image. For me, this image is the largest contentful paint.
Mm.
Time blocking, so how much time your server took to respond this. Layout shift is what happens, right? So if I refresh this page, you can see the image bounces a bit. So that's layout shift. Speed index, I don't know. It also gave me suggestions what I can do. There are few render blocking requests, font display. I can improve the fonts, font colors. So yeah. Oh yeah, this is fetch priority. It should be applied to the image. So it's saying me that for this, this is the largest contentful paint for me. So I should apply a fetch priority as a high. So as soon as as the browser gets the HTML, it will start fetching the image. Uh, so that is how it will work. So there is network dependency as well over here.
So
So I
yeah,
need
Janvi,
to.
this is an absolute world in itself, and it's a really fun world if you really want to get into it. And optimizing things like this is a lot of work and things like that. So yeah, it's an entire world in itself,
Yep.
but a fun one because you really get to understand and learn what it means to optimize a page. And I'll post some resources as well for this, because there's tons of things that you can do around this world. But yeah.
Oh yeah.
A lot of
Uh,
money in this.
her Karthik also sent an image. So I sent a link for this. So this will track like results from previous one to the current one. So you can compare where you moved from and moved to. I guess this is built by Google, right? Web.dev.
Yes, it is Google's. It is hosted, so you don't have to worry about extensions. You don't have to worry about people using different versions of Chrome. I think you can also. They used to have it as a plugin. I don't know if the plugin still exists for Webpack or as a CLI, but I think all of that has been superseded by this.
Yep. So I can improve on the time to first byte.
Page speed insight is mostly for like your prod applications. It collects your data over 30 days and then it averages out across multiple devices that use Chrome. So its application is a little different compared to Lighthouse.
Hmm.
And it will tell you over time whether the performance has increased, decreased, how has it performed, under what conditions.
So yeah, if your site has a lot of users, you might see some information here as well.
Yeah. And Janvi, I posted a link in the chat as well, which is
Let's see
getting head,
google.com to this.
it's called Get Your Head Straight, which is about your head tag in HTML and how you optimize that. Very interesting.
So yeah,
Thank you. Yeah.
Google's own site is very bad.
But okay, do we have any more questions for Darshan before he can just give us a summary of his talk and things like that? Does anyone have any questions for Darshan, please? Okay,
Okay,
hearing
I'll
none,
just
seeing.
summarize this.
Yep.
Yep. So let's go to this home first. This is again uh, a static site, simple one. If you go to the CSR, it's client side rendering where you ship the JS to the user, and the browser is responsible for building everything and managing everything. All the transitions inside your once the site loads is through this uh, React server component. That is the flight protocol. Interesting bit about this flight protocol is you can stream the response as well. So every response could like be a segment itself. As soon as it's generated, it will send that. Uh, so that's there. Uh, SSR is very good if you want to give a fresh data to the user every time. Sites like sites like what somewhere where you want to regenerate every time the data changes. But I don't see a lot of sites that might be using this because it's wasteful, uh, like a lot of time. The dashboards are all. I think every dashboard should be built using client side rendering. It's very simple to manage a dashboard using this strategy. SSG is all your newspaper sites and everything, like small blog posts where you might have like 100, 200 blogs. You can uh, you can build them at the runtime, at the build time, all the sites, and then ship just the HTML and CSS to keep it simple for the users. And finally, we have this ISR, which is a combination of SSG and SSR, and also some of client side, not client side, but SSG and SSR. It will build everything on the browser, on the server, or at the build time, and then incrementally with time, it will revalidate and expire the cache for the user. And finally, this is the streaming where you would stream response with time. So let's say if a segment is like we get a response for the first segment, we'll show that and let other thing load with time. So that's streaming. So if you are building a dashboard or a page For the user, I would say dashboards are all with client sides. You can try SSG or SSR and sprinkle some streaming on top of all the strategies you can have. So no single strategy is the king. It's just that depending on what segment and what kind of uh, audience you have, it matters, and what size of content you have, obviously. Yep, that was it. Thanks a lot.
Awesome. Thank you so much, Darshan. Appreciate you giving the talk. Also, for people who are on the call, please fill out the OTC catch-up survey link pasted in the pinned comment. Really would appreciate all your input. Doesn't matter if you've been attending in the past, have not been attending, anything like that. Please fill up that survey form so that we can improve OTC catch-up. And with that, Darshan, thank you so much. Appreciate you giving us your time and your knowledge, and look forward to having more talks with you and spending more time organizing OTC events with you. But okay, thank you.
Thank you.
Alpesh.